Assalamu alaikum and welcome to another exciting episode of PCME. I'm your host Omar Mubashir. In today's episode, I will be discussing some past paper questions related to the static electricity chapter. So let's get started. So the first question that we have here is from October-November 2017, paper 4, third variant. Question number 8, it says that figure 8.1 shows an uncharged conducting sphere of an insulating stand placed close to a positively charged rod. As you can see here in the diagram. Now, first part of the question here is, the rod and the sphere are not moved. Describe how to charge the sphere using a wire connected to earth and explain whether the sphere becomes positively charged or negatively charged. So this is a two-part question. So in the first part, you have to describe how to charge the sphere using a wire, and in the second part we have to tell either if it is positively charged or negatively charged. Now, if you have watched my previous videos in electrostatic induction, I actually explained how to charge a sphere. So the first step will be connect the earth wire, and then now what will be the second step? Remove the earth wire. And last, what we will do? Remove the charge. It's really important that you keep in mind the order in which the wire has to be removed first, and then the charge rod has to be removed in the last. So this is the first part of the question. Now the second part is in which you have to tell either the sphere will become positively charged or negatively charged. Now, if you remember, when I was discussing about the electrostatic induction, I explained to you that the charge which will be induced on the sphere or on the object that you want to charge will always be opposite of the charge rod. Now, since the charge rod is positive, so what charge will come on the conducting sphere? That's right, it will be negative. So the sphere will be all right. Now let's move to the next question. Now in part B of the question, it states that figure 8.1 shows a small circle that represents a positive charge. Now on figure 8.2, draw the pattern and direction of the electric field in the region around the charge. Now again, two things we have to draw. Number one, the direction of the electric field around the charge rod, and number two, of course, the pattern. So pattern and direction. Now if you remember from the video that I explained the electric field lines, how to draw the electric field lines, so you will use that. Okay, so positive charge rod, remember for a charge rod, the electric field lines will be radial. Okay, so you will draw the radial lines spreading evenly in all directions. So you left, right, up, down, and then you can do some diagonal lines also. You have to excuse for my lines, they are not perfectly straight, but surely you can use ruler and pencil to draw the lines perfectly. Now since this is the pattern, and as far as the direction is concerned, for the positive charge rod, for a positive charge, the direction of the electric field lines will always be outward. So draw the arrows in the outward direction, and that will be the pattern. So there it is. Now let's move to another question. So next question is from May-June 2017, paper 4, first variant. Question number 10, part A. It says, describe the movement of charge that causes an object to become positively charged. So which charge moves, which is responsible for making an object to become positively charged? Now if you remember, when I discussed the charging of an object, I explained to you that it's always the electrons or the negatively charged particles in solid objects that move. Positive charges cannot move because positive charge are basically the atoms which have lost one electron. Okay, so in a solid object, we know that atoms have fixed positions, so they cannot move. So it's always the electrons or the negatively charged particles which move. All right, so given the scenario, what will happen is that the electrons will move, all right, or negatively charged particles. Next up, figure 10.1 shows a negatively charged rod which is held over an uncharged metal sphere, as you can see here. Now, the first part of the question is, on figure 10.1, add a positive and negative signs to represent the result of the movement of the charge within the sphere. Now, as you can see here, I have already drawn the negative charges. Why? Because the negative charge repel each other. So you have negative at the bottom, while the positive charge will be up close like here. So you have a higher concentration of positive charge. Now please keep this in mind. When you have to draw the charge distribution like this, make sure you draw equal number of charges. And by equal number of charges mean that since I have drawn 4 positive charges, so there are 4 negative charges. If I will draw 5 positive, then the negative charge should also be in same amount. Now the reason behind that is because every time when an atom loses an electron, 2 charges are created, positive and negative. So if 10 atoms lose the electrons, there are 10 negative charges produced. At the same time, 10 positive charges are also produced. Okay, so that's why they will always be equal and even in number. The second thing that you have to remember is the charge distribution that you are showing. Now keep this in mind, as I said before, positive charges are not moving. It's just the representation of which end has a higher concentration of positive and which end has a higher concentration of negative charge. One more thing keep in mind, guys, that every time when you have to draw a charge distribution, the minimum number of charges that you have to draw is 3. You can draw more than that, but at least it should be 3. And by 3 means like 3 negative charges and 3 positive charges. Okay, now number 2 is describe the action that must be taken to obtain an even distribution of positive charge on the surface of the sphere. Now this is a similar question like the one we just discussed before in the previous paper. Okay, and that will be connecting the earth wire and then removing the earth wire and then removing the rod. So basically it's just a repeat again. So there it is, guys. I hope you understand. Let's move to next question. This question is from May-June 2018, paper 4, second variant. And the question says, an uncharged conducting metal plate rests on an insulating support. So if you look at the diagram, these are the insulating supports. Insulating supports, like they are made up of insulating material, like wood or plastic or such thing. And on top of it, then you have this metal, this yellow one is the metal plate. Okay, and on top of it you have a plastic sheet placed. Okay, and it has a positive charge on it, which is clearly shown in the diagram. Now the first part of the question is, describe any flow of charge that takes place when the plastic sheet is placed onto the metal plate. So what will be the movement? Describe any flow of charge that takes place when the plastic sheet is placed onto the metal plate. So it's always the negative charge, right? So you would say the negative charge in the metal sheet or in the metal plate towards the because opposite charges attract each other, right? Now on figure 10.1, second part, on figure 10.1, draw how charges are now arranged within the metal plate. So due to this rearrangement, you will have a higher concentration of negative charge on the upper side. So let's just say negative, 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 and on the bottom you will have higher concentration of what? Positive charge. Okay, there you go. And that's it. Simple as that. Finally, state and explain if this arrangement of charge helps to keep the plastic sheet in place. Now, guys, keep this in mind. It's a two-part question. The first part is state, and the second part is explain. So the statement would be either yes or no, and then you have, and the second part is explain. So since this question is for 2 marks, so 1 mark is for the statement and 1 mark is for the explanation. This is how the marks are distributed in these type of questions. So state and explain if the arrangement of charges, this one that you have just drawn, that I have just drawn, will help to keep the plastic sheet in place. Well, the statement obviously will be yes, it will. Why? What's the reason for that? Because, so the statement will be yes, because opposite charges attract each other, right? As you can see here, you have a higher concentration of negative charge close to the metal sheet, the plastic sheet, and opposite charges attract each other. That's why it will help to stick, because of the force of attraction. Okay, yes. Due to the force of attraction between opposite charges. Now let's move to the next question. Part B is figure 10.2 shows 2 uncharged conducting spheres suspended on an insulated thread. The spheres are now both given positive charge. Both are given positive. That's the key point here. Now on figure, draw a possible position of each sphere and thread, both of them. So sphere and thread, both of them you have to draw the new possible position. Okay, now we already know that like charges repel each other. So when both of the spheres will have like charge, they are going to repel each other, and because of that, what will happen? Their positions will change, so they will move away from each other. So you just have to draw the new possible position. So here will be the first one, and here will be the second one. Approximately a way clearly showing, oops, you have to excuse me for my drawing, it's very bad of yours. Anyways, that basically shows that this will be the possible position because of the repulsion between them. Now explain the position you have drawn. So why does that happen? Because the like charges repel each other. So okay guys, let's move to another example. This one is Specimen 2020 paper 4 question. Now the question says that a plastic rod is rubbed with a cloth and becomes positively charged. It was neutral before, but due to the friction, it becomes positively charged. Now after charging, the rod is held close to a suspended table tennis ball shown in figure 9.1. The table tennis ball is covered with a metal paint and is uncharged. Okay, now what are the keywords you have to understand? First of all, the plastic rod which is being rubbed, and what's the charge on this? Positive. Then you have the table tennis ball which is suspended, and this one is neutral, uncharged, right? It's uncharged, but it has a metal paint on it. All right, so describe what happens to the charges in metal paint on the ball as the positively charged rod is brought close to the ball. So what will happen? Since it's a metal paint, so it has free electrons in it. and those free electrons will be attracted towards the positive charge. So you would say that the negative charge or free electrons, either way it's correct, okay? The negative charge will move towards positive charge rod because opposite charges attract each other. All right, now the ball is attracted towards the charge rod. Explain why this happens given the ball is uncharged. This is for 2 marks. So first one, obvious, opposite charges attract each other, right? And the second reason is because there is a higher concentration of negative charge to the face close to the charge rod. Okay, so both of these reasons together, number one, opposite charges attract each other, and number two, the concentration of the negative charge is more closer to the charge rod, and because of that it gets attracted. So first point, opposite charges attract each other. And then the second point is there is higher concentration of All right, so the next question, and which is also the last question, is that state the unit in which electric charge is measured. I hope all of you remember from my videos that it's coulombs, named after the scientist. So what's the SI unit? It's coulombs. Simple as that. See? Alright guys, that's it for today. I hope you liked the video. Thank you for watching. See you next time. Bye bye.